Up here is a photo of microplastics that were collected from the Toronto Harbor. So these are, relatively large microplastics. But what we're concerned with is these plastics, of course, but also much smaller in size. So how did we get here? Well, the use of plastics really were on the rise after, in the 50s, after World War II, and plastic was this great material. It's durable, it's flexible, it's low cost, and it's very popular because of all these traits it has. And this sort of convenience that we got from plastics, single-use plastics, has really led to this issue of contamination. So we really do have a global contamination problem with plastics, large and small. So it's ubiquitous from equators to poles, from Lake Ontario to the ice in the Arctic. We have microplastics everywhere, in freshwater and in seawater. So the scientific literature has really, really exploded in the past few years in microplastics and plastics in general. And although there's always more to be understood, there's now enough science to know without a doubt that this is a serious issue that we need to start addressing. So microplastics aren't a simple single contaminant. They're really a complex mixture of unique compounds. So as you know, there are a variety of different types of plastics. And with all these plastics comes a variety of different shapes coming from different products, different sizes. They have different additives. And in the environment, they can sort of absorb a different mixture of chemicals. Whatever's in the environment could absorb to plastics. So there's a variety of different microplastics, like I said, and they come from a variety of different sources. So one of the major ones that has now been essentially outlawed is microbeads. So plastics manufactured directly to be small for the use of an exfoliant. But these days they're mostly banned in Europe and North America. There's the single-use plastics we know of, which unfortunately don't always get recycled, get into our environment. We have microfibers coming from polyester clothing and cotton from our laundry, and a very large contaminant is also tire dust. So from your tires, the rubber from your tires is quite a large contaminant. And there's a variety of shapes of microplastics: fibers, fragments, films, and there's many more different polymers that are plastics themselves than what's up on here, but there's a few common ones. And these plastics often have different additives. So since the sort of dawn of plastics, there's been over 8,300 million metric tons produced, and only about 2% of those plastics have been recycled for a similar use, and 6% have been recycled for like a downgraded use. So as much as we try to improve our habits of recycling and plastic use, there's still the vast majority of plastics we use are not being recycled, and they're ending up incinerated or discarded in the environment. So we have this pretty obvious issue of plastic pollution, not seen as much here at home, but around the world there's a lot of scenes like this. It's kind of staggering to see how much plastic pollution there is on beaches and in the water. So there's a lot of different sources of microplastic, and the trends in research are sort of going more towards how can we improve efficiency and the economics of different processes, but the flow of plastic is going more and more into the environment. So we have millions of metric tons per year of plastic entering the environment, and there's a variety of different sources, from wastewater treatment plants to just plastics we use every day. And unfortunately, the flow of plastics tends towards the environment. And what really sparked a lot of interest in microplastics is this discovery of the Great Pacific Garbage Patch. So essentially, the way the ocean currents flow is happens to be that they sort of circulate around the Pacific near California, and there's another one on the side, like in Asia as well. But so we see this large patch of plastics in the ocean that's twice the size of Texas. And when you think of it, you sort of imagine a large floating mat of plastic bottles, but it's really not that. What it is it's a mixture of very, very small plastics, microplastics. So anything smaller than 5 millimeters down to about 1 micron in size. So that's smaller than the diameter of your hair. So once these plastics are in the environment, large plastics, they'll break down over time from the effect of the sunlight. The UV will break down the plastic smaller and smaller, as well as the action of the waves, and they sort of erode. So these plastics, once in the water, are eaten by animals because they look similar to their food source, algae, very small plankton. They fall to the seafloor, and they travel, like I said, in the ocean through ocean currents, and that's why we're seeing even microplastics in the Arctic, where there's no sign of human life. Well, there is now, unfortunately. So over 800 species of animals have been affected by microplastics, and they've found that through a lot of research, that there's a lot of growing interest in this field. So there's a huge effect on our environment, and that includes products we use every day. So microplastics have been found in sea salt because the levels are high in the ocean, and when we make sea salt from the ocean, there's some remaining microplastics in there, and as well as our seafood. So we're seeing microplastics in a lot of the seafood we enjoy, unfortunately, from shrimps to mussels to lobster and freshwater fish even. So the effects are sort of varied, because there are the effects that we see from just large debris that birds will ingest, whales will ingest, and there's some pretty staggering images that you can find of animals affected by plastic that's killing them. And then there's also the chemical effect. So whether it's the plastic themselves, which is having an effect on the animal, or the chemicals that attach to the plastics, either in the environment or are there from just the manufacturing process, the different additives they have. And these chemicals can transfer from the plastics to wildlife, and they're definitely seeing some transfer of these plasticizers and plastic monomers themselves to the animals. So what does the medical literature tell us? I'll briefly go over this because Joanne will do a full presentation on this, but we know that plastics smaller than 150 microns can be uptaken by the body. So anything larger than that will likely pass through us, but the smaller plastics are of the most concern. And these smaller plastics can have different effects on sort of different parts of our bodies, from the macromolecules, DNA, proteins, to cells, to tissues, and to organs. So it's a variety of effects from small to large. And we see that small enough microplastics can actually go into organ tissue. So that's these fluorescent green dots are This is in mice. So we're seeing plastics actually like crossing into organs and tissues. So it's important to understand that like we need to first understand what the effects are before we can determine if there's a massive issue. So I don't want to be all doom and gloom because we really don't know, but and that is the kind of scary part. But so it's important to look at like the pillars of food security. So we know there are some ecological impacts. We know that there are some physical or particle toxicities, and we know that they do alter nutritional value. Like I said, some fish will selectively eat microplastics because they don't know the difference between that and their food. So even here at home in Lake Ontario, we're seeing large concentrations of microplastics, even higher than what we find in oceans, because oceans are so large and dilute. But in lakes, in freshwater, we're actually seeing higher levels of microplastics, which wasn't originally the biggest source of research, but in the early 2000s, people started looking into freshwater, and they found that microplastics are in higher concentrations in freshwaters than the ocean. And my focus in research is mostly on drinking water. So I look at microplastics in drinking water. So if plastics are in our water, lake water, then it's very difficult to ensure that there's none in our drinking water, because unless you have like a clean groundwater source, which is one good thing. That groundwater is essentially microplastic free. So, but globally, they're finding microplastics in tap water. And here are some examples. So you have a small blue fiber, could be from a pair of jeans or a sweater, and then we have some smaller, more commercial looking, like a bright green foam. And these are images I took under microscope of just tap water. So there's been a lot of studies done about bottled water, and it happens that just through the process of manufacturing bottled water, it has like almost the highest levels of microplastics we see in any water. So over from 100 to 6,500 particles per liter in bottled water. And in tap water, like I said, like a clean groundwater source will have like almost no microplastics, but some studies have seen as many as 600 particles per liter of microplastics in drinking water. And just looking at the waters themselves, this is not drinking water, but like the lake waters themselves, we're seeing, less populated areas will have less microplastics just because a lot of the input is from wastewater treatment plants, or, populous areas have more pollution, so there's more plastic contamination. So Lake Ontario, has much higher levels of microplastics than, say, Lake Huron or Lake Erie. And like I said, so just laundry, washing a fleece sweater can release almost 100,000 microfibers. But although wastewater treatment plants remove almost 95 to 99% of microplastics, that 5%, if like I said, one sweater will release over 100,000 microfibers. So that's every household. So it's almost 4 million microplastic particles per facility per day are entering our lake waters, even from a wastewater treatment plant. And that's with 95% almost being removed. So it's a very large problem. So how can we mitigate microplastic pollution in our environment? So really being careful about how we use plastics and what we do, and recycling is a big step we can take. If we're capturing and treating more urban runoff, that can also help, because like I said, a lot of pollution we see is from tire dust. So if we're through more green drainage, we can remove a lot of these microplastics. If we improve our wastewater treatment plant technologies, even though they're removing 95 to 99% of microplastics, there's still that 4 million microplastics per day entering our lakes. And of course, reducing our single-use plastics is massive. So what's next? Well, California has just adopted this piece of legislation, so they're trying to they're really the first state or any sort of body to adopt a microplastics strategy. So they're first trying to define what a microplastic is, because like I said, it's such a mixed bag really. There's so many different plastics and shapes and sizes, so it's hard to define. And they're going to start monitoring it and reporting it and sort of determining for the first time if microplastics are as big of as an issue as we think they are, and what the long-term effects are. So overall, our shared goal is to turn this mess that we've put in place to a nice clean environment how we found it.
I'll be discussing plastics and human health. And my presentation, and I'm afraid because my computer isn't here, I may have to turn back to see what's on my slides. The plan of my presentation is to look at history and current issues, some of which Sam touched on, some of the sources of plastic exposure, the types of plastics that we are exposed to, what they do in the body, and I'll be providing you research evidence on human health, and we'll leave with a few outstanding issues. So the history. The Plastic-ene Epoch began in 1869 when Hyatt developed cellulose as a substitute for ivory when elephant tusks were becoming rarer, and this was for the billiard ball industry. It was 30 years later when Baekeland in Europe invented Bakelite as a synthetic shell for insulating electric wires. But it wasn't until World War II where plastics really took off, with nylon being used for parachutes, ropes, armor, helmet liners, and plexiglass for aircraft windshields. When the war ended, it wasn't known what to do with all this plastics, and its use in human consumption exploded. In 1955, there was, as Sam showed, this iconic issue of Life called the Throwaway Living Issue, and it said that most plastics are discarded within 1 year of manufacture. In 1968, Dustin Hoffman, playing Benjamin, and I forget the last name, was told by Mrs. Robertson's husband to find a career in plastics because this is where money was going to be made. So today we're surrounded with plastics, from the toys, the containers, the drinks, the plastic bags, coats, eyeglass lenses, beautiful furniture, and well-designed, styled furniture, and medical cell phones and medical applications are huge, as well as prosthetic devices. Cars are mostly made of plastic. Indeed, plastic consumption has grown 400-fold since 1950. And the current consumption is estimated, depending on reports, between 300 and 400 pounds per person per year. And this is expected to explode over the next 30 years, 1,400-fold. But unfortunately, we can't get rid of it. And plastics, more than 90% of recyclable plastics are still in landfills. China is the major producer and polluter. And this is a cousin who was on a holiday in Taiwan and didn't know what this was she was seeing on the beach, but this is what shocked her. The other side of the plastic epoch is in 1960s, there was growing awareness that the ingredients in plastics may be harmful for human health and reproduction. And Rachel Carson's book, Silent Spring, in that era, started to make us, I mean, she dealt with other synthetic chemicals, but it made us aware of the harms. And indeed, her book led to the Environmental Protection Agency in the US. In the 1970s, there were increased rates of childhood disorders being noticed, and these were on the increase, such as autism, ADHD, learning disabilities, childhood cancer, and pediatric psychiatric disorders. And these levels were beyond that of our ability to diagnose these diseases. In the 1990s, primarily led by Theo Colburn, who wrote the book Our Stolen Future, the possibilities were raised that the two phenomena were linked and that the timing of exposure was critical. Also, in the 1990s, there were scientific discoveries on rodents fed plastics directly that of genital abnormalities. And in the 2000s, plastics and other environmental chemicals were suspected as acting as endocrine disruptors. That is, they interfered with hormones. And I partook at the American Thyroid Association with Tom Zoller in the first, this is 2002, Meet the Professor session on endocrine disruptors. In 2004, the seminal publication on microplastics came out. But in this issue of National Geographic, beautiful imagery, it is realized that we're just at the tip of the iceberg. What are the sources of plastic exposure? They come from consumer use, where they enter the body through the skin, through breathing, through eating, and from environmental exposure, the soil, the air, and the water. They also are a major contaminant of people working in all the industries, from extraction to refining to waste management. In fact, pickers are at very high risk. But so are people who live near these sites, referred to as fence-line communities. Here you see a child's playground and a refining industry in the background, and here cows eating, likely cows for the market, near a refining industry. So I Googled plastic manufacturing near, and I found 3 plants in Newmarket, 7 in Bolton, 11 in Barrie, 1 in Alliston, and 1 in Shelburne, and 8 in Orangeville. And if we look at the center, the area where we are today, and I've blown it up, here's the church. There are 4 plastic manufacturers near here. And can I say it? My dogs used to be groomed right here on Stewart Street. So what are the different types of plastics? I would like to classify them just by adjectives. They're the hard, the soft, the foamy, and the tiny. So what are the hard? These are the polycarbonates, made up mainly of the chemical BPA or bisphenol A. There's more recently, when this became banned, two replacements developed, which current research suggests they may be even more harmful than BPA. BPA was originally surprisingly developed as a synthetic estrogen, and it's the most studied of the plastics. And here, as I've just said, the replacements have recently been developed, but research in humans is, I think, non-existent. The high levels of BPA are also seen in amniotic fluid, breast milk, and blood, and the Centers for Disease Control report 92% of children's urine samples contain BPA. The soft are the polyethylene, like your black plastic bags, your saran wrap, IV bags, and milk containers. But what's also harmful in these are the additives. And this includes the phthalates, which are used to soften, shown here in containers, and even the gel on the capsules we take our fish oils in. These are referred to as poison plastics because they migrate readily into food and beverages. Another additive are the flame retardants, PBDEs, polybiphenyl diethyl esters, as found in furniture, televisions, and PFAS, perfluoral acrylic substances, or Gen-X or Teflon, and seen inside the containers of the little boxes the restaurants give you when you take home your food, and rubber coats. The foamy are the polystyrenes, which I don't have to talk about, from cups to noodles. And the fourth class, which Sam dealt with so beautifully, are the microplastics, under 5 millimeters, and the nanoplastics, the size of sand under 100 micrometers. These were directly added to cosmetics, but now banned. And there is also, as Sam has said, the breakdown of the plastics that enter the environment. And each of these examples, he described the tires, the microfibers, and water bottles. But this is the major source, surprisingly, the microfibers from wash water. They contain the basic polymers that I've just described and the additives from BPA to flame retardants. And they also adhere to them are what are referred to as chemical hijackers, which include chemicals banned from production, like DDTs and PCAs, but are still in the environment. Sam has described the research that we ingest through tap water and through bottled water, with, in one study that he listed, over 92% of bottled water contain microplastics, and of interest for this community, a bad offender is Nestle, especially if you buy it from Amazon. Sam, Nestle is not liked here because they take our water. And there was something like 1,200 times the amount in the sample. A source of contamination is the bottles, the lubricants in the bottles. We've heard about microplastics in the fish and seafood we eat. It's also found in feedlot foods given to poultry and cows. We've heard about sea salt and sugar and beer, and also honey, where plastics in the air fall on flowers and the bees take it away to make their honey. So what do plastics do within the body? Well, most of the forms I've described act as endocrine disruptors. And what do I mean by endocrine disruptors? And here's a little bit of basic biology, but the endocrine system is a chemical messenger system consisting of glands which produce distinct hormones. Hormones produced in glands travel through the bloodstream to often distant organs where they carry out key biological functions. So if this is a depiction of the endocrine system, on the male side, this includes the testis, which produces testosterone, the ovary, which produces estrogen, the pancreas, which produces insulin, the adrenal glands, which produce hormones important for things like metabolism, blood pressure regulation, stress reactivity, and the thyroid gland, which is the one I've studied, which produces two hormones, T3 and T4, which are critical for brain development and brain function, and also do functions such as regulate the heart and fat metabolism. All aspects of the system are vulnerable to the effects of different plastics, and from my reading, those shown in red seem to be the most affected. But research may in the future tell otherwise. So why do plastics act as endocrine disruptors? Sam has shown us these chemical structures already, but they are composed of these rings, these six-sided rings called phenol rings. And estrogen, testosterone, and thyroid hormone are similar, also made up of these rings. And BPA works on estrogen primarily. Phthalates work on testosterone or serve to block or interfere with testosterone and thyroid hormone. And flame retardants interfere with thyroid hormone. And actually, the drawings aren't very good because this takes over. But these two constituents are very, very similar. So whereas the BPDEs have bromine, 4 bromine molecules attached to them, thyroid hormone has 4 iodine molecules attached to them. BPA acts by blocking the estrogen receptor, so the genes that would be normally regulated by estrogen don't function. Phthalates block by more closely at the gene site, this is a gene, by blocking the chemicals that activate the genes and so block gene expression. And flame retardants act by binding to thyroid hormone receptors and by suppressing hormone actions. So what is the research evidence on the health impacts of different plastics? And I'd like to start of the different, and I will be describing 5 specific plastics: BPA, phthalates, flame retardants, polystyrene, and microplastics. I'd like to start by looking at the levels of research evidence. And if we go up in quality, so the higher the level, the better the quality. And this pyramid shows the different kinds of studies, from ecological studies, case series and case reports, cross-sectional studies where a section of the population is studied for its exposure and recorded, and often and cohort studies where samples are followed prospectively. So, for example, mothers, their biological levels are measured, their levels of plastics are measured during pregnancy, and their offspring are followed out to often, as far as we know, to adolescence. In one of these, there are levels of research that involve the merger of population databases. So like in Scandinavia, they will put together prescriptions. They'll look at diseases in pregnant women and then look at prescriptions such as Ritalin for ADHD in children, link the two, and come up with statements about the disease. These are observational, and I have a red asterisk here to say these studies, which I was involved with, they take a lot of time, and they're very costly, and take a very large staff and commitment to carry them through. There are also two kinds of experimental studies on human: non-randomized control trials, where you have a control sample not exposed and a sample exposed, and the randomized control trials, which is the where people are assigned to one group or another. And I'll be describing it, but there is only one that I know of with plastics. And ultimately, there are signed systematic reviews that pull together all the evidence in a very systematic way that combines them. By and large, most of the evidence in humans has been observational, but we've also learned a lot about plastics from animals studied over multiple generations, and in the plastic work from what's called in vitro studies, where cells or tissues are grown in petri dishes, and some are exposed to the plastics and some not. So what are the health effects in animals of BPA? It's associated with abnormal oocyte or egg development, abnormal in the male offspring, abnormal prostate and testicular development. This is in rodents. They show altered sex-related abilities, and the effects are transgenerational, with you expose in one generation and their grandchildren are studied and show effects. And this is really true for the new BPFs and BPSs. I'd like to show you the research, and this will be the only piece I show, of Jody Flaws at University of Illinois. She studied egg and testicular development. In normal egg development, in utero, during pregnancy, there forms this germ cell nest, which breaks down towards the end of pregnancy. So these individual eggs develop and grow into a mature follicle that can later be interact with sperm and be fertilized. In the normal, this is a section from a normal adult rodent whose mother was exposed in pregnancy, and this is what she has found. It's really shocking because I was there to hear her present it originally. The ovaries of the exposed rodents still had these nests. She's also reported more ovulation problems, more mid to late gestational problems, and litters with fewer pups, including some litters where all were dead. So what about humans? During pregnancy, there's more preterm births and more sons with genital abnormalities, namely cryptorchidism or undescended testicles. So in those whose mothers had high levels of exposure were more likely to have this testis remaining in the tube in the abdomen, and the scrotum being empty compared to normal anatomy. And when their children were studied, more had learning and behavior problems, namely ADHD, anxiety, aggression, and social problems. When children are exposed, they show more social, learning, attention, and conduct problems. Adolescents reportedly have more mood problems. This was the only randomized controlled trial I know of. There may be more, but I don't know of that. And this is a study out of New England in the School of Dentistry, where they took 534 children and randomly assigned them to receive amalgam fillings or these beautiful, like I have now, composite fillings that are made from BPA. And what they found was the BPA group had lower neuropsychological test scores, but IQ was unaffected. They reported more psychosocial difficulties. The girls had more body fat and later menarche, their periods, but there was no effect whatsoever dentally. What are the effects in adults? There is reports of more male sexual dysfunction and reduced sperm count, and among workers in factories where there's exposure to BPA, a higher incidence of prostate, ovarian, and breast cancer, obesity, and type 2 diabetes. What about the phthalates that are added as in containers and the pills? These are known to have anti-androgenic and anti-thyroid properties. Studies in rodents report abnormal male and female genitalia, meaning that the distance between the anus and the genital opening is reduced. Poorer sperm and semen quality. So here this is a normal sperm, and these are what are seen in the exposed animals. See no heads or heads only. And these are the cells within the testicles that are normal cells. And after exposure, there are these large vacuoles with far fewer sperm. There's also premature reproductive senescence, meaning the rodents stop being reproductively active and were infertile much earlier, which may have human implications, and abnormal brain development with fewer neurons in the frontal lobes. In humans, during pregnancy, there's reported more difficulty getting pregnant and staying pregnant, and more children with the same kind of genital abnormalities, early puberty, ADHD, and disruptive behaviors. And one study of boys showed less masculine play. They preferred neutral toys than typical boys' toys and didn't engage in as much rough and tumble play. In children who are exposed show asthma and allergy, and in this one non-randomized controlled trial involved a disaster in Taiwan where phthalates were used as a replacement for vegetable oils given to people. So they studied those who were in the areas that received it versus those who didn't, and found lower IQ. And among adolescents who are exposed to phthalates, more maladaptive behaviors. Among workers, there's greater incidence of liver damage and tumors, brain, lung, lymphatic, and blood cancers, and thyroid dysfunction. What about the flame retardants that we see in our carpeting and our furniture? These migrate readily into air and dust. They're found in 90% of blood samples, including from newborns, and toddlers and young children show levels in the blood that is higher than in adults, which is not surprising because young children crawl on carpets. The studies show that children have reduced neuropsychological, motor, and attention abilities. And in this study from sick kids, what they did in the urology clinic was look at the hair samples of boys who had hypospadias, which is abnormal opening of the Moira, what's it called? The AGD opening, the the urogenital opening. And their mothers had far more BPA in their hair samples, signifying exposure in pregnancy, and the children had higher levels in blood. What about polystyrenes? These, in my readings, have not been studied to the same degree. They migrate readily into foods. They're a known carcinogen, but we did do studies years ago on the children whose mothers were exposed by working in industries, and their children showed poor concentration and abnormalities in color and contrast vision. I had a lab all set up to study this, and the children had poor visual spatial abilities. According to Bruce Lamphere, and I recommend you to look at, it's quite a shocking 7-minute video, Little Things Matter. He says even small doses, or he shows even small doses may be harmful, and the effects are cumulative across all the exposures. In 2019, the European Union did their did a report on plastics, and it does recognize there's a sizable impact on human health and the environment that contribute to disease and dysfunction across the lifespan, but large knowledge gaps still persist. So let's just look at the microplastics as was described earlier. It's an area of emerging research. Not that much has been done on humans. And microplastics may show additional sites of vulnerability within the body beyond endocrine disruption from component plastics. In fact, 2 sites of suspected vulnerability are the lung, and I'll show you after the gut. So in the lung, they travel in, some are cleared, but not all, and go down into dendritic cells where they can enter other tissues such as the heart, brain, and endocrine glands. And they can also be transmitted through the placenta in pregnant women and breast milk in lactating women. The nanoplastics, this is my reading, and I may be wrong, to me may get infiltrated into the lung itself, doing damage damage to the respiratory system. The gut has 2 modes of entry. The microplastics can enter directly and go through and ultimately land up in the lymph system, causing inflammation. They can disrupt the microbiome, and they can, once entering the circulatory system, can affect secondary tissues such as the liver, the brain, and the endocrine glands. The smaller particles can also be kneaded through the gut by a process of paracellular persorption, and I, a sufferer now, wonder whether these can cause damage to the lining of the human gut. So also this year, the World Health Organization did a report on microplastics in drinking water and says there's currently a paucity of information to quantitatively assess any potential risk. And they conclude with there's insufficient information to draw firm conclusions on the potential risks at this time. The Guardian picked this up and said, microplastics in water, no proof yet they are harmful, says the WHO. But what I heard on the radio and saw in other reports is microplastics in water, no proof they are harmful, says the WHO, leaving off the yet. So in summary, most forms of plastic act as endocrine disruptors that lead to genital, reproductive, and neurobehavioral abnormalities, and the specific abnormalities may reflect the type of plastic, from BPA to phthalate, and the timing of exposure, pre or postnatally, childhood versus adulthood. And occupational exposure in the plastic industry and fence-line communities are high levels of areas of exposure. These represent groups at serious risk. Microplastics serve as vectors of plastics and the chemical hijackers which enter key organs of the body, and they may be especially harmful because they can also invade the gut or the lung, causing these organs to be hurt. I'd like to leave you with two outstanding issues I was thinking of. One is, what is the impact on recent and future generations? Since most samples have been studied, I'd like to just track back. With the growth of plastic production and the increase in plastic waste, most studies of the samples were conducted on populations born before 2010, when the levels weren't as high as now. So what happens to the children of these women who are pregnant in these more recent times with greater exposure? These 9-year-olds and under, we don't know. The other is, what is the impact of extreme weather events? Because we're all concerned with climate change and the fact that weather is getting worse. A year ago when we had this meeting, we had a terrible snowstorm with 2 bad car accidents nearby, holding up the entry of our audience. So I remembered this story about a plant in North Carolina that produced Teflon, and they found high levels in the Cape Fear River system downstream from the plant and in hundreds of private wells, the plant by DuPont. Recently, studies following Hurricane Florence report high levels of Gen X in the wells, 20,000 times the state provisional health goal. What does this mean? So in conclusions, plastics pose a significant threat to human health. To identify the specific harms, much more research is needed, especially on microplastics, the impact for future generations, and from climate change and extreme weather must also be studied.
For me, the journey started because I am not an activist. I'm a journalist and a writer. But it started when I began thinking about writing a letter to the editor of our, we have a little local newspaper, an independent paper in Creemore. And I thought, because it occurred to me that this issue bothers me, the plastics issue. But it occurred to me that that Creemore is the ideal community to actually get something going, because it's really small and contained and it's quite progressive. And so I wrote a letter to the editor saying, who wants to join me on making Creemore plastic, single-use plastic free. And I knew as soon as I did that I would be starting something, and did it with great reluctance, I have to say. But indeed, that's exactly what happened. I got a lot of response, so I started a Facebook group. That's been a bit controversial because not everybody's on Facebook, and so, you know, a lot of us are of an age, and, you know, we don't do social media, but it actually, from my point of view, was the best way to mobilize people who are interested in this issue. I mean, immediately I got 100, now we're up to 140 members, but that happened right away. So, and what pleased me about that was that a lot of them are younger people, because as far as I'm concerned, this is their issue, this is their future, and I really wanted young people to be involved. I wanted to get into the schools. Actually, I didn't really have any firm idea of anything, but, and I knew nothing. But my main goal was to get our council, we're in Clearview Township, to support a motion on a voluntary ban of single-use plastics, namely, you know, straws, stir sticks, plastic bags, water bottles, all the usual suspects. And I worked with our councillor, who was very, very interested and excited about this. So he was hugely helpful. We modeled our motion on one that the town of Blue Mountain had just done. We talked to people in Bayfield, because they had just recently been declared the first plastic-free community in North America. And then in August, we took the motion to council, and they passed it. And for our council, which is really, really conservative, like they're resistant to just about everything, they passed it. So we weren't necessarily surprised about that, because I really think that municipalities are very interested in this issue right now, because the Chinese aren't buying our crappy garbage plastics. And so most municipalities used to just be able to sell this stuff to the highest bidder, but now they have a landfill crisis on their hands, and so they're really listening to ideas like this. So I think that the time is, we're really on a wave, and it's going to be the legislation's, you know, Trudeau's promised that by 2021 they're going to ban all this stuff. Companies like that are getting on the bandwagon. We have been around to talk to businesses in our community, including, you know, chains like Sobeys, and they are very open to anything that you suggest. And everywhere I go now, and you just see people, awareness is just so great. So, so I started a group called CLEAN. It's actually, it stands for Clearview Eco Action Network. So it actually was an older group, so sly. And then we had a local artist design a logo for us. So even though we're just a virtual organization, the logo really made us feel real. We printed up stickers that have the logo, and then they say plastic-free zone. We give them out to businesses who want to put them in the windows of their businesses. And we've just found that nearly everybody is in favor of this. You know, nearly everybody wants to do something. And that's why it's such a great issue, because plastic is in all our lives. And we understand it, and we know what we can do about it. So, so we're just moving ahead. As with most of these things, you guys are really lucky because you have MC Squared, which is, I mean, you're so well organized, and you've been around for such a long time that, you know, I mean, you're just poised to do something about this. We're kind of starting from scratch. And as always, it's the same people who do all the work. But one of our farmers market was very interested. Talk to your farmers market. They really want to go green. The Shelburne market already has. I don't know about Orangeville. Go to your BIA. I went and spoke to the BIA. I got letters of support from the BIA and from the farmers market and from other organizations in town, and just took them to council. We took we pulled a Greta Thunberg, and had 9-year-old Hazel Dempsey come and speak to council, and she was wonderful. And we've really, really had a great time. But the most fun we had, and I'll just show you. So if you could go to the other 2 slides, the before one, and we had an arts festival a few weeks ago in Creemore, and so we wanted to do a guerrilla art, trash art installation. And so this is the fountain. If any of you have been to Creemore, it's like Creemore's landmark. It was sculpted by Ralph Hicks and donated to the village, and it's children dancing around a water thing. So the night before the arts festival, we gathered in the dark, and we had been collecting plastic trash. We'd asked our members online to save all their plastics, and they were dumping them at my house, and my husband was getting a bit upset. The garage was like filling up with plastic trash. And then that night, before the opening of the arts festival, we got all the kids too. They had such a great time. We made a chicken wire cage around the fountain, and we filled it with trash. And all the little figures, the children are carrying bags on their backs of trash, and it caused quite a sensation. It was really neat, and it also, some people were very angry. One man was yelling at my husband and saying that it was going to lower real estate values in Creemore. Yeah, so, and people were saying, well, I know I want to be an environmental activist, but does it have to be so ugly? And then the paper, they ran a picture on the front page the next week, and they wrote a wonderful editorial about it. But the message was so direct and so impactful. So that was like fun. I mean, this is all such a sad story. It's kind of good to do something like that. But anyway, that's sort of where we are. We're handing out shopping bags outside supermarkets, like reusable shopping bags to shoppers. We're planning on designing our own shopping bag. We're running a draw on, we got this company called True Earth. I don't see you have it over there, but they do laundry strips. Have you seen them? And they're like soap wafers that you come in a package, and you just put it into your washing machine. It's great. No more big laundry jugs, plastic laundry jugs. And they have donated tons of this stuff to us, and so we're going to organize draws. We're going to raffle off books on how to give up plastic. And so I don't know what else I can add to that, but I think I've taken up enough time. That's where we are. Thank you.
I have a practical question about plastic containers, which I think are one use. You buy peanut butter Harmony, or at Bulk Barn you can use a plastic bag or a container. I think they're either 2 or 5, I'm not sure, and freezer bags. Now I reuse those things, and I want to know if they're harmful, if I should stop using them. I kind of feel that maybe chemicals are leaching out, maybe they're breaking down. How long does it take before they start breaking down? And where can I go online to get information like this? Those are my questions.
I guess that's to me, and I can't answer it except no, I don't need it. I'm in the same situation as you. I always like to marinate meats in a plastic freezer bag, so I stopped doing that because I was afraid of the chemicals. I think we have to realize that they do leach out, and just be careful and cautious. I think and I'm happy to email anybody the PDF of that. I did have my email address. But I think if you look at those levels of harm, which I got off the internet, I think if you could just adjust life according to what we know now is safer than other things, you use those. But really try to keep away or reuse things you would normally throw in the garbage. I realize now I sent to the road too many garbage bags, the blue, the clear, and so I'm filling those up more before send out. It's the little things. But I think what Cecily says is so remarkable because it really takes a village to start an effort, and I think Creemore has done that, and I think we have to be more active. Our children have to be more active. They're the Justin Trudeau's generation, and our grandchildren. You know, they as the kids in Creemore and little Hazel Dempsey, who made a very poignant presentation before her council. Just get the children involved.
Are we just endangering all the wells of all the people who live off city water?
So it's a very poignant question because that's currently like where we're at in research right now is we're investigating the effect of plastic piping. It's really important, I think, when we're talking about this is to understand the amounts we're talking about and what the true effect of those amounts are. So plastic pipes aren't leaching millions and millions of particles. They're probably mostly inert, and they're not releasing that many particles. And depending on the piping, I can speak to drinking waters. When they're using plastic piping, they are like inert plastics that don't leach as many chemicals. Like they're specifically designed to be safe. Oh, sorry. Yeah. So plastic piping, specifically designed for water use, is designed to limit leaching of any harmful chemicals. And so, yeah, the research right now we're doing at the University of Toronto, the Drinking Water Research Group is looking at different effects of plastic use in water. But I don't think, just speaking with my personal opinion, I don't think that the use of plastic piping is causing this a lot of harm. But what we do see in terms of farming is that a lot of times wastewater treatment sludge is used as like a fertilizer on fields, and that's where we get a lot of microplastics being added in the fertilizers on these fields. And speaking to algae blooms, you're exactly correct. It is the fertilizers, like with the increased water temperature and the nutrients from the fertilizers, that's specifically the cause of algae blooms, especially near to those areas.
Thank you. This might be a question for Sam. I'm wondering if you know whether reverse osmosis would take the microplastics out of the water.
Yeah, so again, this is, sort of doesn't sound that cutting edge, but it's sort of our cutting edge research right now is looking at all the different methods. Of course, reverse osmosis membranes basically remove, everything from water. However, they are made of plastics themselves, and you have to replace them every so often. So what's happening as these membranes degrade, that's what we're looking at as well. So as these membranes degrade, are they leaching plastics? That's...
Hi, so I have to say I breathed a sigh of relief when you said plastics weren't in groundwater, because we do have a well. And then I thought of how much laundry I do and how it's going out into the septic tank and the weeping lines, et cetera. So thanks for that image in my head. So what I'd like to know is there any research going on getting plastic out of our bodies and out of our system, or is there any way of doing that? Like, is there any?
So like I said in my presentation, anything like larger than sort of a grain of sand is sort of passed through us. It's the smaller plastics that would affect cellular activity and get uptaken into the gut lining and lungs, and over time those do degrade, but we don't know specifically the long-term effects, and so the research is still sort of just starting to see what the long-term effects is and sort of the levels there.
Can I say something? I have a colleague. He helped me with some of the information I started with. He works at the EPA, and he was all set to go with a lab hired and everything on microplastics and human health, and Trump pulled his funding. So this is going to take a while.
I wanted to follow up on a question beside Fred. I don't know the person beside you, but okay. About the part about websites. And I wondered if, as an audience and panelists, we could all share websites that we find helpful and relatively reliable information. And I just wanted to mention one that we look at a lot. It's called EcoWatch, but maybe other people have other ideas.
I might just say, if you go on Facebook and join our CLEAN group, it's called CLEAN, capital C, uppercase LEAN. We post all kinds of stuff from all over the place, from articles that people find in The Guardian and everywhere, and news about new products and stuff. So right there, it's a excellent resource for that kind of information.
This is, I know we've heard about this, and I just want to know if there's real data on it or what we can do. What I understand is that in the drinking water, because it's coming from a plant, this is in, subdivisions and so forth, all the drugs that people take, all of the, there's just so much that is, how does it get taken out of the water? Does it make it out of the water? It's not just drugs, but other things I can't think of right now, but that's the big one.
Yeah, so this sort of research started about 10, 15 years ago, and there's some things you need to put in context. For example, all of the water you will drink in your entire life from tap water, the amount of a drug won't add up to like the equivalent of one aspirin pill. So yeah, antibiotics and like hormones from birth control are the more worrisome, because in very small amounts, so antibiotics aren't in the levels they are there. They like have been shown to not really have a long-term effect or cause antibiotic resistance. But the worrisome one is hormones from birth control, because even in very, and I'm sure Joanne can speak to this more, but even in very, very small amounts, hormones can have effects. But there are treatment technologies in place to effectively eliminate them from our drinking water. Yeah.
Can we find the best place to put the pressure on and multiply the pressure so it's not just one squeaky voice?
I have something I could say to that. I don't buy them, for one, is one way of doing it. But another is what I do now, and I'm encouraging everybody here to do this. It's sort of civil activism, which is leave the packaging in the store. So the more of us who do that, the more it'll get up the chain from the retailer to the manufacturer to the producer, that we don't want this stuff anymore. So I take the rings off and put the ginger ale cans in my bag. At home I cut them up for sure, and also the little flip tops that come out. You buy a Tetra Pak of chicken stock or something, and the little thing that comes up, And like I've seen birds beak, you know, photo images. Anyway, so I take the plastic packaging off. I buy lettuce, you know, baby lettuces, and I take my own bags and I empty the lettuce into you have to take the thing to the cashier because they need it to scan it. But I've never had anybody complain, ever. As a matter of fact, the store manager at Foodlands in Creemore told me to do this. And so, anyway, I think that, this packaging is the whole thing. And then we need to put pressure on our governments to make the manufacturers of these products pay the cost of cleaning it up. Because right now it's you and me, the taxpayer, that has to deal with all this stuff and pay for it. So I can get quite militant talking about that. But I mean, I think we have to push back. Well, ask the cashier to do that. Say, I want you to cut those rings before you throw them away. I'm sorry, I can't hear you.
Sure.
Yeah, well, you know what? We have, Creemore's known for its beer. So the Creemore beer people, they used to have, it was like a black plastic things on top of a six-pack of beer cans that was plastic. You couldn't recycle it. And don't get me going on recycling, but anyway, you couldn't recycle it, but they sourced something else which is made out of beans. They got it from Ecuador or someplace, and it's a plant-based material that they use to, so, you know, they're getting it. You know, I mean, Sobeys is banning plastic vegetable bags. You can buy reusable vegetable bags in Foodland too. So it's coming, but, you know, we need to speak up. Yeah.
Okay, I guess this question is for Arnold. I was wondering if plastics are recycled, how many times they can be recycled to a usable product? Because every time that they're recycled, the quality drops. So, and at the end, what happens when they cannot be recycled anymore?
So only 2% of plastics can be recycled to like a similar value that they were before. Or sorry, of the 8% of plastics ever in production, only 2% have been recycled to a similar value, and the other 6% are recycled to a lesser value. So I don't know exactly how many times something can be recycled to a similar value, but they're not, you know, taking a peanut butter jar and cleaning it and reusing it. They're always melting it down and somehow reprocessing it. But, you know, one example is like clothing and shoe manufacturers are using downcycled, recycled plastics like to make shoes and other products like that, and that's sort of there's some more sort of activism coming from you know, larger corporations because us as consumers are demanding it, and that's sort of like we've all been sort of reiterating that us as consumers ultimately have the power to, you know, push the hand of big corporations and government to, you know, make products that we want.
The private sector sometimes responds to what people want. For example, I have a Brita jug and filter that will filter the chlorine out of my drinking water. Now, has anybody heard of the private sector responding to people's wish to filter out the particles of plastic from their drinking water? Is there any movement at all in that direction? So this field is, to give you context, is about like, in terms of drinking water, it's about 1.5 years, 2 years old. Not to toot my own horn, I may be the first person to graduate with a PhD in microplastics in drinking water. Like, it's a very new field. So, you know, they haven't really
no corporation has said that we'll create a product. Like I said, reverse osmosis membranes will remove microplastics. The only question is what happens to these membranes over time. There are, more evolving and new technologies, ceramic membranes that likely will do a similar thing, but they're not necessarily readily available to consumers. So in terms of BPA, probably the largest scam ever orchestrated by the industry is putting this BPA-free label, because as Joan said, BPF and BPS are just as bad, if not worse. Silicone, it's really hard to just sort of, like I said, plastics are, we call them plastics, but they're all completely different, chemical compounds with different structures and different effects. So it's really hard to sort of paint it with a broad brush, and some plastics are more harmful than others. Some are relatively inert. Silicone is relatively inert. It's really hard to say, because it's all about context and serving size, so to say. How much are you intaking and how much does it affect you? Because if a grain of something can kill you, and a grain of something can be completely inert.
For those of us that are on wells, is there some place that we can actually take a sample and get it tested for microplastics?
No. The methods to test for microplastics are new and evolving and aren't standardized, a test for chlorine or arsenic or lead or iron. They're not at that level yet.
So sweet. This probably sounds silly, but we all have to wash our clothes. Is there anything we can do?
Yeah, so right now there's been a few studies done. There's different products available for purchase that will reduce how much microfibers leave your washing machine. There's sort of, something called a Coraball, which does an okay job, and then there's putting a filter on the back end of your washing machine, which does the best job. And there's a pilot project going on right now in Perry Sound. So they installed a lot of these filters on washing machines, and they're studying the effects and how much it reduces the load of microplastics to the water. But one of these big issues right now is that, of course, a appliance manufacturer, the last thing they want to do is put something on their machine that involves more operation and maintenance. But I mean, we have lint traps on our dryers now, so why can't we have a filter on our washing machine?
Sam, one more question. I don't drink bottled water, but I have a question about it. So you said that well water has very little or no microplastics. So when some of the bottled water makers claim that it's well water, how do the microplastics get into that? Does it leach from the bottle, or is it the processing?
So it's just from the manufacturing process in the factory, as well as there's a study that came out recently, and it showed that it's not the plastic from the sides of the bottle that's breaking off and leaching into the bottled water itself, but when you open and close the lid on a plastic water bottle, that will increase the microplastics in the water. So if you are reusing a plastic water bottle, then you should definitely try to avoid opening and closing the lid. But also, it's just inherently from the process, there's microplastics everywhere, and especially in a factory setting, there's high levels, and it's a plastic bottling facility.
I wonder if you could just follow up on the question about using silicone?
Yes, like I said, you know, some plastics are more inert than others. Silicone is definitely more inert than, yeah. It's yeah.
Just a quick one here. As I understand it, the Dufferin County waste disposal contract is up for renewal at the current time. And it seems to me that it would provide a really good opportunity to talk with one of the biggest waste disposal companies, probably in North America, and start talking to them about how do we get past the 9% that is recycled. And so I think that, I'm not sure there's an immediate total answer to this, but there may be several steps that they could take, and we working with them through our councils and as individuals that might start to address this as in our county, and maybe try to turn it into something like Creemore is in terms of raising hell about this. Sorry.
Yeah, so it's really difficult because no matter what, like the municipality does, the entire public has to buy in. So like I couldn't name you all the different things that you can and can't recycle in the city of Toronto, and like all these different regulations that you would never be able to memorize off the top of your head, and all the different plastics that can't be recycled. You can't recycle black plastic in Toronto because the sensors can't pick it out. And there's so many different, like if you don't perfectly rinse all your plastic before you put it in recycling, it's going straight to trash. Like there's so many different things that the public doesn't know. The information's available, but it's not spread well enough. It's everything around recycling. Again, it's not a scam, but it's just really hard to actually do it well. And like it's not everyone has the best interest at heart, but they don't know all the rules, and it's hard because there's, I said, so many different polymers. And
we're in Simcoe County, and we did contact the waste management people, because waste management is a county-wide thing, and they were very interested in our group. They're very interested in getting all the public support that they can. They have a real situation on their hands, and I personally feel that recycling is just a snake pit. I mean, who knows? I mean, for instance, so these lovely cups that you have here, there's a little thing that seems to indicate that they're compostable. So, or maybe they're made from recycled material. I don't really know. Or maybe they're recyclable, but they're what? They're recyclable. Are they compostable? Yeah. They're compostable. Well, there's a difference, though, because compostable means you put it in the compost. If you don't, it's not going to biodegrade. It needs the right conditions of moisture and heat. So these cups, you're all going to take them and throw them in the trash. It's, and then they're going to go into landfill, and there's a plastic, maybe there isn't, but to be effective, they have to go into a composter. So I suggest that if there isn't a composter here, that you take them home and put them in your composter at home. But you see, nobody knows any of these things. And that little triangular thing with the arrows on it that's it's the little logo that means it's recyclable? I read this in The Guardian, that has never been patented, that symbol. Anybody can use it, and I assume anybody does. So who knows? And you're right, like one, lettuce leaf stuck on the clamshell that you put in your recycling bin can contaminate an entire load of recycling. So recycling, and we've all been taught or conditioned to rely on recycling. And we say, oh, I recycled that. But I think we really have to put more emphasis on using less plastic at source. So use and reuse.